8.4, factor and solve polynomial equations. We have a general trinomial here that we need to factor. Factors of 2 are only 1 and 2, so that's going to be 2x times x equals 2x squared. And then I need factors of 20 when it's multiplied to this 2 is going to equal -3. Factors of 20 would be 1 and 20, 2 and 10, 4 and 5. Let's try 4 and 5. If I put 4 here and 5 here, I get 10 and 4. Doesn't work. So before I get rid of the 4 and 5, I'm going to switch them and put 5 here and 4 here. Now we have 2 times 4 is 8, and 5 times x is 5x. Now we have 2 times 4 is 8 and 5, an 8 and a 5. So the middle term is 5x, and the outer term is 8x. So 5 and 4 work. Now I just need to get the signs in there. I need a -3. So that would be -8 and positive 5x. -8 comes from here, 2 times -4, and then the 5 is positive, and that is fully factored. A perfect square trinomial. A perfect square means you're going to have the same thing in both parentheses. It's a square. We have x times x, and that would be 4 times 4 is 16, and positive 4 plus positive 4 equals 8. Here's the factors. And now my final answer would be x plus 4 squared, a perfect square trinomial. Here we see the difference of squares. 9 is a square, x is a square, and 1 is a square. So the difference of squares means the same thing in both parentheses, and then a plus and minus. The sum and difference will give no middle term because you have positive 3x and then negative 3x. The difference of 2 squares always has the same thing in both parentheses, but a plus and minus. Common monomial factor. Monomial means 1. This is really the first rule of factoring. Is there something that I can pull out before I try the general trinomial factoring? What do they have in common? They have a 4, and they also have an x in common. So I would like to divide that out. When I take out 4x, that's going to be 8 divided by 4 is 2. X squared divided by x is x. And then 20x divided by 4x is 5. I can check to make sure I did it right by just multiplying it back together. Distributive property. 4x times 2x is 8x squared. And then 4x times 5 is 20x. Factor completely. Okay, I'm looking at this, and I can see they both have a 3 in common, and they have an x. So I'm going to divide out a 3x. 3x cubed divided by 3x is going to be x squared. And then negative 12x divided by 3x is -4. Again, you can just check by distributing that back. Here is a difference of squares. So we still need to continue factoring. That's 3x. We have the difference of squares. That's going to be x times x, 2 times 2, and a plus and minus. Now it is fully factored. Example 1. Factor polynomial completely. All right. I'm looking at this, and I can see that it's a degree 3, and they all have an x in common. I'm going to factor out the x. X cubed divided by x is x squared plus 2x minus 15. I took an x out from each one of them. Now I need to try factoring the quadratic that's here. X times x is x squared, and we have 5 and 3. That multiply to 15, and I need a positive 2, so it would be positive 5 and negative 3. B, we have a 2, and we have y cubed they both have. So I'm going to factor out a 2y cubed. And here we have y squared minus 9. Now we have a difference of squares. So y times y, 3 and 3, and plus and minus for no middle term. Example C, we have a 4 and a z squared. Going to factor out 4 and a z squared. Let's see, that leaves z squared minus 4z and plus 4. I'm going to continue trying to factor. We have 4z squared, z times z, and then -2 and -2 would multiply to 4 and add to -4. -2, -2. And here I want to make sure that I'm cleaning this up. I've got a perfect square, trinomial square here. So we're going to do 4z squared times z minus 2 squared. We want to make sure that we are simplifying our algebra. And here we can see that we have 2 of the z minus 2's. Final answer. Okay, we have the sum of 2 cubes. This is different than what we saw in the previous chapter. This is the sum of 2 cubes, not a cube of a binomial. We want to make sure that we are not confusing what we did in the previous section of a cube of a binomial. This is not the same thing as the sum of 2 cubes. These are not the same at all. They are similar, but they are not exactly the same. We see here that when I have a cubed plus b cubed, I'm going to take one of each. I'm going to keep the sign that's here. And then I've taken one of the cubes, so that means in the parentheses there's 2 left. This is where you're going to see that it's similar to the other pattern. I take an a plus b. That leaves 2 of them. So here's my a squared, and then on the next term, the a term goes down as the b term appears on the second term. There are no more a's left, and the b exponent is going up. So the beginning process is different. The beginning process is different, but the pattern of exponents will be similar. The other thing that would be different is the signs on these. When I have a sum, I take exactly what I see here and then I alternate the signs. That was not so when I had a plus b cubed. It was all plus. So the signs are different and the technique is a little bit different. All right, here we go. The sum of 2 cubes. Well, I want to make these look like cubes. That would be my first step. I would have 2 cubed and x cubed plus 3 cubed. But again, I want to make it look a little bit more like the formula. And that way I could say that 2x is being cubed plus another cube. Now that is looking exactly like the formula. So we take 2x plus 3. Now it's a cube, so I've taken already one of the 2x's away. That leaves 2 of them. There are 2 of the 2x, and then it's minus. There is 1 more of the 2x, and this is where the second term comes in, 3. So we're multiplying by 3, and then we have, there are no more 2x's left, but there are 2 of the 3's, so 3 squared. That is the pattern. Now you need to make sure that you simplify everything. So we have 2x plus 3 times 2x squared is 4x squared, minus 2 times 3 is 6, so minus 6x, and 3 squared is plus 9. Now we do need to make sure that we are completely factored. Will this factor anymore? It is a degree 2. And so you should always check to make sure that you're completely factored. So by trial and error, I could try 2x, 2x, 3 and 3, and we get 6 and 6. That's not going to add to 6. And we could try 1 and 9 before I get rid of my 2's. We have 18 and 2. That will not add. So I've tried all the factors of 9. Now I'm going to switch out the factors of the 4x squared, which would be 4 and 1. So we'll start with 1 and 9. We have 36 and 1. No, that doesn't work. Switch your 9 and your 1. Now we have 9x and 4x. No, it's not a negative 6. So now I'm done working with the 9 and 1. I'm going to switch to 3 and 3. And that would be 12 and 3. I'm not going to switch the 3 and the 3 because it would be the same. So I've tried all of the factors of 9 in the combinations with the 4, and I did not come up with anything. So we have our final answer. If I needed to continue to solve, then I would just use the quadratic formula on this part, and I could solve this linear factor very easily. Final answer for factoring. Example 2, now we have the difference of cubes, and the pattern is the same. It's going to be a minus b, and then it's all plus signs. First thing, need to make this look like a cube. So that's going to be 4 cubed, x cubed minus 1 cubed. And again, 4x cubed minus 1 cubed. Now I have the difference of cubes. I can clearly see what those numbers are going to be. So we take exactly what we see, 4x minus 1. Now I've used up one of the 4x's, so that means that there are still 2 of the 4x's. Plus, all plus signs. Now there is only 1 of the 4x, and this is when our 1 comes in. So I'm multiplying by 1, and then plus. Now I have no more 4x's, and there is 1 squared. And I just need to simplify. 4x minus 1, and then 4x squared is 16x squared. Multiplying these all together, we get 4x, and then 1 squared is 1. And again, you would want to make sure that it's factored completely. I know that it's factored completely. But if you do not know, you should try to factor. X cubed plus 64, example 2. It's x cubed plus 4 cubed. X plus 4, exactly what you see. And now there are 2 x's left, and we're alternating our signs, negative. The next term is going to have an x times the second term comes in, plus, and now we have x squared x. We have 4 to the 1, and now it's going to be 4 squared. And simplify. Example B. Is there anything that I can pull out from all of these? We still need to remember that. Let's see, is 250 divided by 16 even? It does not work out evenly. How about 250 divided by 4? No. All right, on our graphing calculator, we do have a way that we can find the greatest common factor. If I go to the math button, I can go over to numbers. Under your math button, remember that's where you can see a cube root, or any root that you want to do. I can also get fraction answers and decimal answers. All right, so I'm going to go over to number. And if I scroll down to number 9, we see that we have least common multiple. We have greatest common denominator. So we're looking for the greatest common factor. If I hit number 9, and then the 2 numbers that I'm using is 16, comma, here's your comma button next to your parentheses. So comma 250, close your parenthesis, equals 2 is the common factor. So I am dividing 2 from both 16 and 250, so that's 2. And I see that I have z squared. that I can also factor out. So that leaves 8z cubed minus 125, and that's it. Now I'm going to change these into cubes. Here's a cube. So if I'm going to factor, these are going to need to be cubes as well. We have 2z cubed, 2 times 2 times 2, minus 5 cubed. All right, now I see my difference of cubes. 2z squared times, I take exactly what I see, 2z minus 5. And now I have 2 of the 2z's. It's a minus, so it's all plus. And we also have 1 more of the 2z. And we're going to multiply by the second term, 5 plus 5 squared. Simplifying where we can. 2z squared is 4z squared, and then 5 times 2z is 10z, and then plus 25. Final answer. Again, you should check your quadratic to make sure it's fully factored, and here it is. Factor by regrouping. Okay. Regrouping means that I'm going to take these 2 terms and these 2 terms, and that's how I'm going to think about them. Factor by regrouping, I am going to think about these terms together and then the second 2 terms together. What can I factor out of x cubed minus 3x squared? They have x squared in common. So I'm going to factor that out. That leaves x minus 3. Now, if this technique is going to work, I'm going to need to see another x minus 3 on the right-hand side. That's how you know that you can use regrouping. Looking at negative 16x and 48, I can factor out negative 16. That leaves x and then minus 3. Now, for your final answer, what you want to do here is we have x squared times x minus 3 minus 16 times x minus 3. We have 2 separate terms here. This is multiplying, so that's all one term. This is multiplying, so it's all one term. The subtraction sign here is showing us that we have 2 terms. Basically, what you're doing is undoing the distributive property. What can I factor out from these 2 terms? I can factor out an x minus 3. When I factor out an x minus 3, what is left? I have x squared. And when I factor out the x minus 3 over here, what do I have left? Minus 16. And now I need to continue to factor the difference of squares. Difference of squares means you're going to have exactly the same thing in both parentheses, but you're going to have a sum and difference to have no middle term. Final answer. Factor polynomials in quadratic form. Quadratic usually means you're looking for something like x squared. Here, they want us to factor in quadratic form. So this is just another technique to look at this. I mean, we could actually just factor this right off the bat because 16 is a square, x to the 4th is also a square, and 81 is a square. But let's do what they're asking in quadratic form. So I want it to look like it's x squared. Here, this would be 4 squared times x squared raised to the 2nd power minus 9 squared. And so here I see that I have 2 squares. That's going to be 4x squared squared. 4x squared, and all of that will be squared. So it still says 4 squared is 16, and it still says x squared being raised to the 2 power is x to the 4 minus 9 squared. And now we'll just do the difference of squares. We have a sum and difference, and it will be the same thing in each parenthesis. So we have 4x squared, and then 3 and 3. And again, what do we want those signs to be so that there's no middle term? That would be plus and minus. So we have 16x to the 4th minus 9, and then the middle term is 12x squared and negative 12x squared. Does it factor down anymore? We don't have cubes. This is not a perfect square. If 3 was a perfect square, then we can continue to factor, but it is not. So that is a final answer. Great. First, we'll start by seeing what can we pull out. We can pull out a 2, and the highest p we can pull out is p squared. So we're going to factor out 2p squared, and that leaves p to the 4th plus 5p to the 3rd. And we have 6. So we have 2p squared. And then p to the 4th would be p squared times p squared. 6 would be 6 and 1. No, it can't be 6 and 1 because I'd have to have a minus 1 and a positive 6. That would not equal a negative 6. I need 3 and 2. Instead, we're going to use 3 and 2 because positive 3 and positive 2 add to 5, and positive 3 times 2 is positive 6. Now we have a p squared here. Does this factor anymore? No, it does not. Final answer. Example 5. What are the real number solutions to the equation? We know that we would like to shift everything to one side. Where's my highest degree? X to the 5th. And my leading coefficient is positive, so I'm going to move my 18x cubed to the left. So that would be 3x to the 5th, and then a negative 18 cubed, x cubed, and then a negative 18x cubed, positive 15x, and that equals 0. Now I can start to work with it. So remember that you always want to have your terms on the same side. Even when it looks complicated, put everything together and then go from there. I can factor out a 3 and an x. We're going to factor out a 3x. So the 3's cancel, and x to the 5th divided by x is x to the 4th minus 6x squared, and then plus 5. And we're going to factor this degree 4, which will be x squared times x squared equals x to the 4th. And then 5 and 1, they both need to be negative. Negative 5, negative 1 adds to negative 6, and negative 5, negative 1 multiplies to positive 5. Now I have a degree 2 here. Will this factor anymore? I have a perfect square, but this is not a perfect square. Here I have the difference of 2 squares. And so this one will continue to factor. We have 3x times x squared minus 5. And now we're going to factor this one. That's going to be x times x, 1 and 1, and then I need a positive and a negative not to have a middle term. Final answer. Example 6. In the city park, let's see, you are designing a marble basin that will hold a foundation for a city park. The basin sides and bottom should be 1 foot thick. Its outer length should be twice its outer width and outer height. So 1 foot thick, and then it should be twice what the width and the height will be. What should the outer dimensions of the basin be if it is to hold 36 cubic feet of water? Well, this is a 3-dimensional figure. That would be like volume equals length times width times height. So we could, let's see, we know that 36, it needs to hold 36 cubic feet of water. And we are multiplying the interior length, the interior will be 2x. It's a foot, so 2x minus 1 minus 1. So 2x minus 2 times, we have an x length here, and it will be minus 1 minus 1. So that's going to be minus 2 for this one, x minus 2. And then for this, it's just going to be x minus 1 for the base. And simplify everything. So for example 6, it would be the same idea as example 5. I would want to shift my 36 over to the right. I'd want to multiply this all out so that I have a polynomial all set equal to 0. I wanted to show you another technique for being able to solve polynomials on your graphing calculator. The first thing that you're going to do is you're going to graph the function. We're going to graph the right-hand side, and we're going to use parentheses. That keeps the multiplication. So y equals, open parenthesis, and 2x minus 2, x minus 2, so another parenthesis, x minus 2, close my parenthesis, open another parenthesis for x minus 1. So there's the first equation. What this says right here is we want to know, when does the right-hand side equal the left-hand side? That's what the equation means. If I graph this side of the equation on the next line, that's y equals 36, and graph. So we're setting the equations equal to each other in the grapher. We graph this equation first, and then y2 would be the second one. We are looking for the intersection. Well, if we have a line that says y equals 36, that means that my y-axis needs to go up to at least 36. And here we're on a 10 by 10 grid, and we are not at 36 up here. So I'm going to go to my window, and I would like to change my y max. I'm going to change that to 40, and I'm going to have the scale go by 5s. So I'm not going by 1s. Graph. Here is where we see that they equal each other at this place. I can do a calculation of where they're intersecting then. So I would go to calculate, that's in the blue. Second, trace. Number 5 is intersect. It's asking you, are you on your first curve? Nope, I'm going to move my cursor. Here's my cursor. Moving up, blinking, and I'm going to have it land right here where I think it's intersecting. And right there. So it's intersecting right there. It's saying, okay, first curve, is this your first curve in y1? Yes, so I hit enter. Is this your second curve, y equals 36? Yes, enter, and enter again. It says the intersection is at 436. We get x equals 4. X equals 4. So what are the dimensions? That would be 4 times 2 is 8 by 4 by 4.